Today we're talking about, let's give it a title for our notes, literal equations, okay? And you guys started with that warm-up. We were looking at distance is equal to rate times time. So I want to catch up with you in your conversations you had. You were trying to tell me, like, you could give me the rate if you knew the distance and time,
Yeah.
or you'd give me the time if you knew the distance and the rate.
Yes.
Can anybody generalize what that means? Like, I can find the distance if I know these two things. Is there a generalization, John?
So basically, if you're going like 20 miles per hour
Mm-hmm.
for an hour, then that would be the rate, which is 20 times 1,
Okay.
because that's rate times time, which is equal to 20.
Okay.
So then you know that you went 20 miles.
Okay, so your distance works. So you guys started plugging in numbers and testing out the equation, right?
Mm-hmm.
But was anybody able to, like, say you could find the rate if you knew the distance and time? Will?
I think Joe and I figured that out, right?
Okay.
Yeah.
So how could you find the rate?
He said the distance divided by the time.
So Will, for my Zoomers, Will saying the distance divided by the time gave him the rate. So
Or the
you could
rate
say,
is equal to the distance divided by the time.
okay, so I'm not sure if this is how they came up to it, but if it's not, we're about to blow some minds, okay? So let's say I wanted to change my equation to a rate equation. That means I want to isolate that variable. So how do I undo times t, Caitlin?
Divide by 2.
I can't hear you. How do I undo times? Okay, so I divide both sides by t. Or, well, I don't know why I crossed that out. And look what we get. Is that what you guys did?
Yeah.
Or did you use, like, intuition to come up with this, and I'm just showing that the algebra matches it?
We filled it out with numbers. Like if you were going.
Yeah, you used numbers to test out and saw that it was the division. Okay, so now that we have a rate equation, if distance equals rate times time, I'm going to ask Tanyan, can you help me find a time equation? Which would just mean I'm going to isolate for this variable t here. How could I isolate that t? You're going to hold space, or you might be on an iPad. You got okay.
Wait, so to find time?
Yeah, goal is t equals, right, for a time equation?
Yeah.
Okay.
It wouldn't be.
So I want to get rid of this, Tanyan.
Yeah.
How to get rid of that?
Would it be rate divided by just.
No, yeah, so divide by rate. You're onto something there, Tanyan. If I divided both sides by the rate, time would equal to the distance divided by the rate. So what's cool is we have a distance equation, right? But we actually have a distance equation, a time equation, and a rate equation. Because if you're like out there in the real world, like a real person may do, really, you might come across a situation where you know a rate and a time, and you're looking for distance, but maybe you don't know the rate. Maybe you know how far and how long, but you don't know the rate, right? So now you have the ability to change an equation and give yourself options, right? Does that make sense? Did we do any new math to do that?
Not really.
But notice, do our answers have any numbers in them?
No.
That's interesting.
You can
to think
test
about,
it with
right?
numbers, but
You
don't
can
have
test it with numbers, but I need you guys to be comfy today having some answers that don't have numbers in them, or it's a mix of numbers and letters, because that is the challenge. It's the optic. The challenge today is going to be the optic. The math isn't too crazy, actually. So let's look at another equation you might recognize. Area is equal to 1/2 base times height. So I think you gathered it's an area equation because I said area, and there's a capital A. What's this area equation for, Mikey W?
One half. The area is 1/2.
Yeah, what's the area equation of?
One half of the area.
Of what, like, this gives me the area of what shape?
A circle.
What? A circle would be pi r squared.
Yeah,
Good guess. So this is half of something.
It's a triangle.
Here's
Oh,
the,
square.
well, here's a square. That'd be base times height, right?
Triangle.
Half of that.
Triangle.
Yeah, triangle. So
It's a triangle.
let's say we knew the area of a triangle and we knew the base of a triangle, but we didn't know the height. So guess what we could do? We can solve for h and we can have a height equation instead of an area equation. So let me show you what this means. I want to get this alone. That's no different than it solving any equation, having a goal of a variable to get alone. Lily.
Yeah.
So if I want to get h alone, what's something I need to get rid of?
Okay.
Well, no, a's not on that side.
Wait,
Can't
is that a B or a 6?
That's a b.
You want to
The b, and we also want to get rid of
Eight.
1/2. Which one do you want to get rid of first? The half? Okay, so how do I get rid of the half? Okay, divided by half, which is the same thing as multiplying by the reciprocal, right? 2. So I'm going to multiply both sides by 2. It actually turns that half into a 1, right? But 1 times stuff is just stuff. Okay, so that means that 2a is bh. What am I trying to get alone again? H. So Henry, how do I get rid of b? Divide by b. Guys, are we doing anything different in terms of solving right now?
No.
No, just don't have letters. We're not doing computation really. Not as much at least. So the height of a triangle is equal to doubling the area and dividing by the base. That's kind of cool. So if you need, let's say you're an engineer or something, I don't know, and you need to find all these triangle heights, but you know the areas and bases, you got an equation, just boom, 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 plug it in. Right? We could have also solved for b, right? Do you guys see that?
Yeah. By just divided by 8.
Yeah, you do a different, but all of our dividing, all of our multiplying, all of our undoing to get to the thing that we don't know stays the same. We got to get comfy with an answer that doesn't have just like 4 as an answer, right? Okay? All right. Let's look at one that I actually really like. Mikey, what's up?
No, it's Tanya.
Oh, yeah, Tanya, sorry. Mikey's was lighting up.
I have a question.
Here, let me pause this one second. Look at this one. We're going to solve for y. And this is something you're going to do a lot in our linear equations unit. This is a line in standard form. If we solve for y, don't worry about writing this part down. But this is slope-intercept form, and that's a different form of a line we'll use for different things. So this is, we're going to practice solving for y now, but this is a skill we'll use a lot when we get to linear functions. So if I want y alone, let's go to Zoomer for this. Let's see here. We want to get y alone. Lauren, what might I do first to get y alone?
Maybe you could be subtracting one of the sides, like either minus or.
What- We want to get this alone, right?
Yeah.
So is there a way, Lauren, you can get rid of that thing?
Rid of what?
This. That.
When I divide it.
Okay, so let's talk about that. 3x divided by 3x would be 1. Does that get rid of it in this case?
3x divided by x. You can divide by. With dividing by
If I
0,
divide this by
right?
3x, I'd be left with 1 minus 4y equals 7. So that
And then you can just subtract
over 3x. Which, I mean, you could, but that doesn't help us much because there's still something there.
What if you divide by
Can you just
0?
get rid of the 3x? Somehow, Lauren?
You divide by 0.
Lauren, what does anything subtracted by itself equal?
Subtracted by itself.
Lauren?
0?
0. Okay, that'd be nice. So check it out.
Subtract 3x.
I'm going to subtract 3x from both sides.
said we don't
So then I have a negative 4y equals negative 3x plus 7. You could also write 7 minus 3x. It's the same thing. Just make sure your negatives and positives are right. All right, Lauren. Next step. I need to get y alone. What other thing do I need to get rid of now?
So get rid of the negative 4.
And how am I going to do that?
So divide it by.
Yeah, I'm undoing that multiplication. So y is going to be equal to Now be mindful, this whole numerator needs to get divided by -4. So that's going to give me 3/4 x minus 7/4. You can just keep that improper. Improper fractions are cool.
Wait.
All right.
3x.
This one looks harder than it is. First hour all freaked out, and then they were like, "Oh, that's not that bad." P equals e squared over r. Now they're all freaked out about a square. Now if we wanted to get rid of a square, what's the inverse operation? We can do it.
Divide by.
Square root, right? Roots undo exponents. But we're going to solve for r, which brings its own set of challenges. So what's an issue with our current r? Where is it located?
As the
Yeah, so like even if we got it alone, it would be like 1 over r instead of r. So how do we get r upstairs? How do we punt that guy up the stairs?
Yeah, how are we going to get r over r?
When we divide by.
Reciprocal. I like hearing that word. So how do you undo divide by r to get it out from the division? Multiply both sides by r. Check that out. It's gone. It's out of the.
What? It's gone?
Well, it's gone out of the basement. Now it's upstairs over here with p. Right? So everybody see what I did there? Now it's no longer in the denominator. But I still need to get r alone, right?
Yeah.
So how do I get rid of that p?
Subtract p.
Divide by p. We're undoing multiplication there, right? So r is equal to e squared p's. I'll just say over p. That didn't work out nice as a fraction term. Like fifths. P's. So again, just be mindful, if your variable's in the denominator, you got to get it upstairs first. If it's in the denominator, it's division. How do you undo division? Multiplication. Again, it's like actually not new stuff. We just have to get comfy with an answer looking like that, right? Yeah, Joe.
You just like switch the r and the p.
Kinda, yeah.
Yeah, basically.
Yeah, that's exactly.
I wouldn't
the
generalize
same.
that, right? I'd use mathematic principles, but yeah, that is kind of what
Like you
happened.
did a bunch of stuff to get there.
Yep.
But like.
Okay,
it took
this
r
one
and
is
the
for
p.
you to try on your own. And you're going to solve for x. So I'm going to start by multiplying by 5. And that leaves me with 3ax minus n equals -20. By the way, you guys remember I was like, communicate your work. Remember, we're going to get to lots of steps. We build good habits with one step. It's going to matter, right? It's happening. All right, Caitlin, what'd you try next?
Then I added n to both sides.
Yeah, I like it. I'm going to add n. I get 3/8x equals n minus 20. Or you could do -20 plus n. Same thing. Okay, so reminder, we're trying to get x alone. All right, what'd you do next, Caitlin?
I divided both sides by 3a.
Yeah, so you could do it by 3 and then a. I suggest 3a at the same time like that. Because 3a divided by 3a is 1, right? 1 times x is just x. And so x is equal to n minus 20 over 3a. And that's the answer. That's what x is equal to.
Yeah.
A little different than something like x equals 4, right? But same principles of algebra. We're just undoing things. And this is nice because if you knew all the other variables except x, now you have an equation that you can just plug n and a into.
Yeah.
The alternative is you could plug everything you know in and then solve for the variable. Or you could solve for the variable, then plug everything in. We have options, right? We've talked about flexibility, right? Math flexibility when it comes to problem solving. That's big. Cool.